that is bent in two different directions and neither of them are what we want. I don't think these pieces are going to make the cut. Would you agree?
Not necessarily.
You think these are salvageable?
Maybe. Well, Christopher.
Yes, Zach?
You jinxed us, buddy.
I did! Last episode I said everything was working well, and it just didn't today.
Yeah.
You're messing with focus here, bud.
I know, but it's fun to do the thing where I'm pointing, and then, I don't know. Why? Anyway. So we came up with a solution that we could do in order to probably do this ourselves and get good results, which would be the same process we did, but along that groove, make cuts and cut relief, kind of like perforations on like something you tear out. Yeah, like a checkbook. And then we would be dealing with much less surface area for our bends, and we could probably bend it up and it would be okay. But that's not what we're going to do. We are going to lay it all out nice and neat, take it to our friendly people at the machine shop, and let them bend it for us.
Say la vida. Right? This is fine.
You can probably hear the raindrops. It's probably not great for our audio.
Yeah.
I don't know. I doubt the smoky haze will show up on the camera. I built a fire and it's a little smokier than usual when you starting. A little chilly, a little rainy today.
The last people saw, we were trying to bend up a long piece of metal for the top of the battery box. And that did not work.
No.
That did not work. So we kind of had to wrap that process up, call it a day, cut our losses, and just move on. So now we have two choices today. We can keep pressing on that same problem, or we can forget it ever happened and move on to something completely different.
Probably move on to something else.
Okay. Well, I kind of was feeling that way too, because we're gonna have to call in some professionals and get some stuff made up for us. Not a big deal. We kind of expected that to happen at some point in time. But that means we're doing something different. I'm Christopher, this is Zach. We are Dream EV on the incredibly fascinating journey of electric car conversions. We're sticking a Tesla Model 3 drive unit inside of a 1980 Vanagon. In this episode, we are not working on the battery box. We're gonna just pretend like it never happened and do something completely different.
Slightly different. We're gonna make the tray for the electronics to sit on in the back of the van. So it's gonna sit right behind the motor because we have ample room in the engine bay, and we're gonna mock up a frame and then we'll sheet it and put a box there. For mounting, switches,
Relays.
fuses, DC to DC converter,
Charge controllers, all sorts of fun things.
Things
Those will
like
go
that.
in the back. I'm sure we'll talk about them when we get there. But right now, it's the platform to put the stuff on.
over there.
All right, this is the area that we're working with. We want to try and get a tray in here that we can mount electronics in. The electronics that we currently have, and room for electronics in the future. So I think the platform that we put everything on is going to be a little bit oversized. And it might look like you're wearing your big brother's pants, but it should be okay. Here are the electronics as we are kind of imagining them to go in the van today. Okay, we have a couple different things that are very important to the operation of an electric vehicle, and we're going to walk you through where the power goes here on the table, so you can kind of get a feel for how everything works and the rationales why we place things here. With this electric vehicle, for orientation, I am at the back, you are currently towards the front and hovering above the motor area over here, right? These fat wires go to the motor and the batteries respectively right here. With that in mind, this is how power enters the system and is consumed by the system. Starting here at the charge plug is the J1772 charge receptacle. Okay. Now, this is what you see at shopping marts. This is what you see in your garage. This is a standard plug that basically everybody's got except for Tesla. Okay. Now, with an electric car, you can't just go plug it in the wall, right? You got to slowly ramp up the power from the charger and the grid, and you got to kind of bring them up slowly. So what happens is you shove some power into this hole right here. It goes through a series of pre-charge resistors. It goes through a tiny little control board, and then it goes into this plug right here. Right, this standard plug goes into our battery charger. Okay. Now, the chargers on the wall at the supermarket, that's not actually a charger, that's just a fancy plug. This is the charger that's in the car. Now, this charger outputs power right here at the appropriate voltage to go to the battery pack, and then this goes into our junction box right here where a lot of the magic happens. Now we got a couple ways in, couple ways out. Big fat orange wires that go straight to the battery, then out to the motor. Both of these orange wires have to come in and go to these big fancy switches right here. These are called contactors, right? And they turn the power on and off, so we don't have to manually. Once the power is split between battery positive negative and the motor battery positive negative, we can tap off of these two contactors and go to our loads. Our loads in these fuses right here. They come out off the positive and onto our accessories. Power heating, electric heating would be an accessory. The 12-volt charge system would be an accessory. If we had a big bump and bass, that would be an accessory. That goes high voltage here to the DC to DC converter that takes our high voltage power down to 12 volts into this orange plug right here. Okay. Then this DC to DC steps it down to 12 volts through these two positive and negative plugs into our battery. And the battery controls the chassis lights, turn signals, horn, everything else on the inside of the cab that needs 12 volts to run. Now the left side of the frame rails, right here on this side, the outside of the battery, is where our 12 volt wiring chassis harness is going to come. So it'll run straight up past the battery, take a turn into this void right here. This void that doesn't have anything in it. Now what we're going to do in this place is we're going to reserve that for future use and or a tiny fuse box. Because we're in the 12 volt area of things, we could put a fuse box. It's right next to where the wiring harness is going to run. It's a perfect space for it. So we reserved this. All of these things are going to be mounted on a sheet of steel with captive nuts from the bottom. So we can bolt these bad boys right in that steel plate and then into the car. Orange wires in our mock-ups are coming out right around this area. And if you'll notice, there's a motor there, right? And we don't want these wires flopping around in this general area. So this is kind of what I've got. And I'm gonna flip you around here and show you, okay? So what we're gonna do is we're gonna take that cardboard and replace it with an aluminum tray of a very similar description. the high voltage power lines will run right in there all nice and tidy, and we can zip tie them down. And that's how we'll span the gap between the battery box, over the motor, and to the electronics tray.
It's amazing. You just mock up a file on a computer, send it to a guy. In a couple of days, you go to his shop, and it's real. That was loud. Here it is, the electronics tray. Fresh from the place where they do the cutting and the bending and the stuffs. We sent them our file, and they did it. So we decided to go with a CAD file and send it to an outside source for a couple of reasons. One would be, you know, it's good to start building relationships for these kinds of things. It's nice to have a supplier for this sort of thing, and to go through that process and learn that process and do it. And you know, and we wanted to use steel because it's easy to do a captive nut and bolt things down, whereas with aluminum you would have to like bolt through it. You couldn't use captive nuts. So we want to go with steel. And to bend a teeny little return on a piece of steel like this, oh my gosh, that would be hell in this shop to try and do. So we went to a professional, and it's just nice to just mock up a file and send it off and it's done. You know, more expensive, but you trade your time or you trade your money. We decided to trade our money this time. Now that we have this, I need to build a frame to set it on. So that's what's next. I'm gonna grab the rectangular section that we have and build a frame. Come, I show you. Come, I show you. I have just finished laying out how I'm gonna cut my rails that will support the electronics tray. I don't know if you'll be able to see any of these little marks here because they're just scribe lines on steel, but this line goes across like that. So I'm going to lock that corner off and drill a hole up here. And so with a hole here and that corner lopped off, we will be able to feed a bolt through here, put a socket on it, and bolt this rail up to the bottom of the frame rails. So this will sit on the bottom of the frame rail. I'll weld it on, and that hole will have a captive nut. So it'll sit there, and this will come and bolt to it. And there'll be another one here, obviously, and then we'll run across and support the tray.
Alright, this is what I'm going to be doing to help Zach. I got a hole saw. I got a little guy that's going to keep me on track. I got some lube to help it go down the hole. Targeted spray action. Patent WD-40 two-way tip. Hashtag not sponsored yet. Oh yeah, easy peasy. So once we get Zach's frame mocked up and placed in, we'll just take that and we'll be ready to set this platform for electronics on top of it.
Here is the tray in place and our components where we're pretty sure they're going to sit at this point. So that's pretty neat.
Okay, I took a look in this general vicinity, and we had the tray in, we had the electronics on, and we were really looking at sizes and dimensions and how everything fits. And where this cable was coming into the battery box was just too tight of a turn, and it wasn't going to work. So we had to step back and do some rethinking. And this is what we're thinking. Right? So if you'll notice, this battery box is now covered in foam and tape and clear plastic wrap. But it's a very important technical mock-up type, step that has to be gone through. This is very normal. But what this is a bigger box that we found that might meet our needs a little bit better. This area right here was giving us problems, is this bar would ultimately interfere with what we wanted to do. Right? We have tons of room, absolutely, don't get me wrong. And we could do it any number of ways. But I kind of wanted a box with a clear lid to begin with, and this pushed us over the edge. What this will allow us to do is to run these wires in at a higher elevation, and there won't be any conflict. Other than that one little change, everything else is pretty much going to stay the same. It is a little bit bigger, but we have the room, and I think it'll look good in the end. We really should be, looking at a battery box and saying how amazing it is and that we did such a great job, but that's not how this episode panned out at all.
It's not like we didn't make progress. We made good progress for what we had, for the time we had. Mm-hmm. I've got the frame mocked up, ready for welds. All the pieces are cut, ready to go. So we can weld the frame up to the tray, and then it's just putting the tray on.
I mean, everything's sized up, it looks good, everything doesn't seem too silly except for this larger than normal box, but it'll be good in the end because you can see through it and you can see the electronics and people will be like, wow, I'm not that interested in electronics, but I'll point at it and I'll be excited.
Yeah.
Yeah.
Yeah. They don't have to be excited, they just have to know that we're excited.
That's all it has, that's all. Well guys, it's been an episode, that's for sure. Like we always say, thanks for watching. Be good people, guys.
See ya.
Alright, here it is. Huh? That's kind of nice. It's a big boy. Yeah. That's an interesting development that I'm real happy about right there. Thank you very much, Arteca, giving us a nice flat surface we can put our own logo into. That'd be very cool.